we just finished our quadratics A unit. So now that we're starting our quadratics B unit, we're looking at the same three forms of quadratics. So we had our three forms. We had vertex, we had general, and we had factored. And if I just quickly write out the three forms, there is your vertex form. This is your general form here. And then this is your factored form. If I were to ask you, say I gave you a test today, like I did yesterday, and I said, all right, we're on vertex form, you need to get to general form. Would you know how to do it? And how would you do it? We're going from vertex to general. How would you get from the vertex form to the general form? What do you think? What do you think, Kate? Couldn't you just, this is your vertex form here. What do we need to do to the vertex form? Just factor it out, expand it out, right? If we just expand that out, we'll eventually get to the general form. What if, instead, I asked you, can you get from the general form to the factored form? You could do that, right? It's just factored. So these two, we know how to do. What if I asked you to go from the factored form to the general form? Could you do that? Yeah. See if I got factors here. All you got to do is just distribute like you did last time. Or just expand them out, just like you did for the vertex to the general form. What if I asked you to go from the vertex form to the factored form? Could you get there in like a step? No. Could you get there in multiple steps? Couldn't you just go from the general form to the factored form? Yes. Okay. That was one of the questions on the test. Maybe. Okay. Anyways, so now we're here. What if I had asked you yesterday, go from the general form to the vertex form? Whoa. Would you be able to do it yesterday? I would have no idea where to start. By the end of today, you will know how to do this. This, going from the general to the vertex form, is what we are going to learn about today. And so, to learn about it, what we want to do is let's just start off kind of easy. Okay? Let's start with this problem here. And for this problem, it's in the general form. Let's just get into factored form. Okay? So take a few moments, get this problem from the general form into the factored form. And I will pause while you do so. Looks like just about everyone got there. So, for this problem, you want to factor it out. What would our two factors be? Yes. X plus 6 and x plus 6. Alright, if I wanted to write that kind of more simply, that's just x plus 6 squared, since it's just two of them, right? From this, if I then asked you, based off of this equation here, what's the vertex of our parabola? What do you think, Nate? Negative 6, 0. So I get we got the negative 6, because here we're in the parentheses, and you can't trust a sign, so it's just negative 6. But how'd you get the 0?
Just like replacing the y and then putting the 0.
Yeah, so there's like nothing over here like there would be if we were in vertex form. So if you wanted to write this out formally in vertex form, we just add that plus 0, because you know that your y coordinate would be 0, right? So if you're ever in a case like this, and your factored form just ends up being some quantity squared, you're in vertex form already. Great, we got one case done, right? Except, what made this so simple for us? What about this formula? What about this equation made it so simple for us to factor this? What do you think, George? It's a perfect square, see? Got a 36. Square root of 36 is 6. So not only is it a perfect square, but if you look at this right here, the square root of 36 is 6, but 6 plus 6, or 6 times 2 is 12. So it works out perfectly for us, right? Is it always going to work out perfectly like this? No, it's not. But we can manipulate it so that we can try to get some perfect cases, okay? So if we said, if I were to give you some equation, like this first equation here, and said, you can put whatever you would like, whatever number you would like right there. Ideally, what number would you put there to make it easy for you to factor? 25. And why would we say 25? How did you find 25? Which part did you look at? So you looked at the 10. From the 10, if you look at it and you say, okay, 10, I know two numbers, two of the same number, have to add up to give me 10. And so if it's two of the same number that needs to add up to give me 10, if I just divide 10 by 2, I get 5. And then what did I do to 5 to get this? 5 times 5, or 5 squared, and you got 25. Cool. Try B and C on your own. I'll pause while you try. Grace, can you tell us what you got for B? Put a 9. And how did you get 9? Okay, and then you got -3. And then you do this squared, and it's 9. All right. Let's see. Who else? Parker, can you tell me what you got for C?
C, got 4.
4. And then did you use the same process of dividing this by 2? And then you get 2, and then you square that? Did you know that this process of dividing by 2 and then squaring it is actually a process that you should always use in these cases, and that Mr. Server calls it half and square, the Dutch boy? Right? It made sense until the Dutch boy, right? But doesn't it sound like a Dutch boy's name? Half and square?
Yeah.
Fun fact, I don't know if anyone's ever learned German. My father went to German school and just completely failed. But he went to German school, and one thing he did learn was the word Hassenpfeffer, which means rabbit. So whenever I hear Hafen square, it reminds me of Hassenpfeffer, and then I get hungry for rabbit.
Yeah,
Hungry.
good.
It's so good. Okay, anyways, so we've got Hafen square, and we call it Hafen square because we take our number, let's call our number n. Get it? Half n square. N. Half of it. And then you square it. So, if you had something like here in D, where you just have b, b is not a number. But, if you do the same process of take b, half it, square it, oh, that would be the ideal number right here, if it was a number. Try out E. Try out this one. It's not going to be as pretty as the other ones, but it's still going to be possible. Okay. I'll pause. Ian, can you tell us what you got for E? Start the process for us. What did you look at first?
The middle number.
Okay, we got 7. What do you do to 7? Divide by 2. Then what do you do? Square it. So can you simplify 7 halves? Not nicely. Then you square it. If you're squaring 7 halves, what do you get? If you wanted to do it in decimal form, you could end up with 12.25. If I wanted to leave it as a fraction, because I like fractions, 49 over 4. Here's how you know if someone is a mathematician versus a scientist. Scientists like decimals, mathematicians like fractions. I'm both. I have no idea what I like. All right. So, yes, question.
Would you also put like 6? Like I didn't put 6. But like, we did 6. No, because can you do 6? Because wouldn't it be 6 times 1 is 6 and 6 plus 1?
So, yes, you could use that to factor. However, using this process that we're doing right here, that is one way that we can factor. This is another way of factoring that we're learning about. Okay? So yes, technically, that is another way of factoring. Okay, but the way that we're looking right now, if you look at this, this is completely unrealistic, right? You could say, Miss P, when is anybody ever going to say, oh yeah, like, here's this real-life application of an equation, but you can fill in your own number over here. That's totally fine. No one's ever going to say that. But if you have an equation, you can manipulate equations to get them to this point. And I will show you how. If I have this example right here, it's x squared plus 8x plus 20. Is 20 the ideal number to have here? No. But if I just cross that out and didn't worry about it right now, what would be the ideal number to write there? We gotta half it, and then you gotta square it, and half of 8 is 4, and 4 squared is 16. So I want x squared plus 8x plus 16. So I'm gonna get it, because I get what I want. Whoa. Alright. Oh, okay. It's alright. No erasers were harmed in the making of this video. Okay. So, if we look back at our original equation here, we have a 20 right now. How could we get from a 20 to a 16? So if I just subtract 4 from that equation, is that okay? Can I just do that? Yes. Okay. So you could just say, okay, let's subtract 4 from both sides. But now on the left side, I've got this y and this number, and I don't want this number on the left side. I just want y on the left side. So instead of writing instead of subtracting 4 from both sides, what if I did something else on this side, so I made it adding 0? Or so I don't change the equation. Would you agree that if I just said, let's add 0, it hasn't changed my equation at all, so it's okay, right? I want to do the same thing, except instead of 0, I want to say, okay, let's subtract 4, and then let's add something else so that we get to 0. So if we add 4 too, isn't that just the same thing as adding 0? And if you look at that, what's the point? Like, look at that, like, we just didn't do anything. We just took away 4 and added 4, right? But if I take this, ooh, darn, okay. Oh no, technology problems. It's all right. It's because the X is on the other screen. It's okay. All right, getting back to this. Getting back on track. Okay. We are at this point where we have subtracted 4, we have added 4, and basically we have changed nothing. But if we take this and just say, so what we really want here is a 16, right? So I'm just going to kind of cut it off right here and group all of this together and just leave that plus 4 alone. Yes.
I'm just wondering, to find the vertex form though, wouldn't it just be faster to find the axis of symmetry?
Would it be faster? Technically, yes, it would. But let me think about it. Hold on. Okay, I know that you can get to the axis of symmetry. From the axis of symmetry, you could find the vertex, and then you could get to whatever the vertex form is. The reason why we are using this method here in relationship to getting to the vertex form is because this is a good introduction to this process, and this process isn't just used to get things into vertex form necessarily. It is used as a mathematical process in other instances, and that is why we're going to learn it, but we're learning it within this kind of area of study, because this way you can check by saying, okay, now let's solve this using the axis of symmetry, and then finding the vertex and putting that into vertex form. You get the same answer. Okay, does that make sense? It is useful. I have used it every year in college. Okay? You will also use it in calculus and honors pre-calc. Okay. If we look at this though, at this point, we are going to take this portion of the equation here, and we're going to leave the plus 4 alone. Once we do, this portion here turns into this equation that we've written that's ideal for us. But then we just have to make sure that we add the 4 at the end, right? Because that 4 is still there. It's just hanging out. If we look at this and just look at this portion of our equation, how can we factor that easily? It's just 2x plus 4s, and then we can't forget the plus 4 at the end. So at this point, if you have 2x plus 4s, that's just x plus 4 squared, and then you have a plus 4, and then all of a sudden you're in vertex form.
Okay, but like, what if like you don't have something nice to work with, like that 49 force on that last problem? Like,
Yes. It'll still work. It is a lot of work. But like, think about it. What if, well, okay, we won't get into that case yet. We'll get into that case tomorrow. But what if it was, or like, for example, what if this was something kind of ugly? Right here, right? If this was ugly, and this was even uglier, you could still use this process and you'll still get to the same point using the same steps. And I know at this point you're just like, I'll just use the axis of symmetry and I'll get to the vertex. And that's okay. But there are also going to be instances when you need completing the square specifically. Okay? So, I would like you to practice one. I will start you off, and then you're going to finish it. This equation here, what would be the ideal number to have here? Half of 14, 7, squared, 49. Or half of negative 14 is 7. And is negative 7, and then that squared is 49. So if you wanted a 49 instead of a 50, what would you put here? Or what would you add on to this equation? Minus 1 plus 1. Okay? From here, find the vertex form. I will pause for a few minutes. Avery, could you tell us the next step you took? Then x minus 7? And then you kept that plus 1 there? Ended up with x minus 7 squared plus 1. Okay. Great. Would you like to do another one, or do you think you have it? You got it? Okay. Then, if you look at the homework for today, I will tell you which of the homework you can skip. So I believe the homework is a worksheet today, like this. And because I want you to have plenty of review problems for when you are reviewing for your tests in the future, I'm only going to make you do half of this worksheet. So, if you look at number 1, let's take off B and C. If you look at number 2, let's take off A and C. If you look at number 3, only do the ones on the left. And if you look at number 4, we're going to continue that, and you're just going to do the one left. Okay. So, it is 1:30-ish right now. Period ends at 1:44. Yes? So about 15 minutes. You have 15 minutes to start your homework. If you have any questions about the drone lab, etc. All right?
If we did it online, or like on an iPad.
The drone lab?
Yeah.
Yes. All right, and so that is all that we have to cover for today.